are.
The first thing that I want to tell you is that we have a test coming up. When?
Tuesday.
It's not on Tuesday.
Oh.
It's not on Tuesday. I
Friday.
It is going to be on a Wednesday. Okay, on Tuesday, we haven't gotten some time to review. So we're going to spend some time reviewing on Tuesday, and then the test will be on Wednesday. It's actually a pretty short test. There's really not that many problems on it. We only have 3 topics that are on this test. You'll be able to get done with it in the Wednesday. I can't move it to Friday because some people are gone. Okay, so it will be on Wednesday. Okay, but we'll have Tuesday to spend some time reviewing. What topics are going to be on that test? 3 topics. What is that? Volume, solids of revolution, right? When we spin something around, what is the volume?
Region between the curves.
The area between 2 curves. And finally, there's one more topic.
3-dimensional block.
Finding a 3-dimensional process.
Yes, finding the volume of a 3-dimensional if we know the cross section of it. Okay, those are the 3 things that will be on that test. It will be on Wednesday, so that on Tuesday when we're in here, we have some time to just spend a little bit of time reviewing for that. Okay. The other thing, if you are going to be gone for soccer on Friday, make sure that you talk to me on Wednesday so that I can kind of tell you what you're missing. How many of you are going to be gone for that? Just the 3 of you? Make sure you come and talk to me on Wednesday. I don't know that I'll have the stuff ready for you before that, but make sure that you remember to come and get it on Wednesday. Okay. What are we going to start working on once we're done with this test?
Review.
Just reviewing. We're going to be hitting that review really hard. Okay. So make sure that you're kind of starting to think about that, right? Going back and looking at the topics and some problems and whatnot. We started the other day looking at these solids of revolution. Okay, I want to give you kind of a warm-up problem to look at. I want you to look at if we have a graph, which is y equals the sine of x. Okay, from 0 to pi. I want you to draw me the picture of what this solid of revolution will look like. Okay, bounded by the y-axis, pi, and the x-axis. Okay, I want you to draw for me 2 ways. I want you to draw me this solid if we rotate it around the x-axis, and I want you to draw the solid for me if we rotate it around the y-axis. Don't solve anything, don't set up any integrals, just draw me what that shape will look like.
The y-axis. Y.
If it is rotated around the x and the y. Not at the same time, but 2 different pictures. On your paper. One if it's rotated around the x-axis, and one if it's rotated around the y-axis. I don't want you to worry about this right now. We're going to actually go through some of these problems today. Just make sure you're working on this problem. What will these two shapes look like? How would you describe these two shapes for me? What if we rotate it around the x-axis? What does that look like?
Almost kind of a circle. Like it's definitely like a round shape. Look kind of like a football.
Sure, kind of like a football. It has a little bit more pointed, right, than a steroid. What about the y-axis? What does it start to look like?
The McDonald's side.
Kind of, but it has to keep rotating, right? On your graph, it might start to look like that. Some of you, I saw you drew something that looked kind of like this. You just drew that McDonald's sign, right? That doesn't really help us to picture what the three-dimensional shape looks like. Make sure that you draw something in there, right, so that we can kind of see that this is rotating, that it's actually 3 dimensions, right? You don't have to draw a lot of them, but make sure that you give it maybe just a little bit of depth so that we see that there's a little bit of a difference between these two, right? In the first one, what method will we use? What method will we use? If we rotate it around the x-axis, what method that we talked about will we use?
Just a normal like disc method.
The disc method, right? It's just a circle. What about the next one?
Washer.
The washer, right? Where it looks like a donut, it's missing that part in the middle, okay? I want us to look at these problems from the worksheet that you started to look at, but there was still some struggles with it. We're going to look at those together. Okay, so our first problem that we're going to look at was if we have an equation which is y equals negative 2x minus 2, y equals 0, and x equals a negative 3. What should be our very first step when we start to set up this problem? Graph it. Draw what is that region? Okay. What does our region look like in this example? If we start to draw these 3 things, what will our region look like? You should have had this part set up, right? And you will end up with your region should look something like this, right? That's our original region. Now make sure when you draw your graph, fill in the region. Otherwise, we don't really know what we're rotating. Okay, so what does the first question ask us to do? What are we rotating it around?
X-axis.
The x-axis. So what will my new shape look like?
Another triangle.
Sure, another one right down at the bottom, right next to each other. Right. Make sure that you draw that at the very beginning so you can visualize what you're trying to find. Don't start writing equations until you have that drawn, until you can picture what that looks like. Okay, in this problem, what things do we need to find in order to set up our integral? What things do we need to find in order to set up our integral?
Big R and the radius.
The big R, right? The radius of the outside one, the little r, and what else? Do we need to know any other information for this?
Well, it helps to know what
Where we're going from, right? Where we're starting and where we're ending. Okay, so what is our big R in this? Does it change or does it stay the same?
Changes.
It changes. So what is it going to be? It must be something with a variable. How do we find it?
I think in this case it's just negative 2x minus 2.
Yeah, it's just this line right here, right? Where it hasn't moved at all. We're not taking anything away from it. So it would be negative 2x minus 2. Technically, we could subtract how far we have moved it, right? But there's not going to be anything here, so we'll have a negative 2x minus 2. What about our little r?
There is one.
There is none. We don't have any hole in the middle there. Okay, so let's find our integral. Where do we start cutting this shape?
X equals
X
negative
equals
3.